And here we go. Hello, everybody. Welcome on .NET Live. We'll have a lot of fun today, an hour, 60-minute kind of-ish of pure fun, unscripted. I'm your host, Frank, but today I'm not alone like usually, right? It's never only one host to bring you all the news. So I have with me Cam. Hello, sir. And David.
Hello, Frank. Hello. Hopefully my microphone's better now.
Yay, we can hear my... Excellent. And the three of us today are welcoming André to talk about some interesting topics. André, how are you?
Yeah, I'm pretty fine. Thank you. What about you guys?
Oh, good. Excited about the news. I think it's a very hot topic you have today. Looking forward to it.
Yeah, that's nice. A lot of things to share with you. I heard you guys like some code, so I brought you about 6 demos to...
Excellent. Nice. The chat love those. And talking about the chat, like apparently a lot of people are already knowing you in the chat, so that's pretty good. But would you like to introduce yourself for those who don't you that much?
Okay, very nice. So I did not prepare in PowerPoint for here. I'm sorry about that.
Don't be sorry about that. It's all good.
Okay, I can write a JSON about myself. That's fine. So I am André Baltieri, 12 times Microsoft MVP. So I work with web development since a long time, and I'm very proud to be part of the Microsoft MVP team. So very nice. I want to talk much about me because I'll let some links here, so you can find me on LinkedIn. You can connect there. So this is my English website, so you can find more content like I'll share you today in this link. This is my GitHub. There's some content in Portuguese there, but I usually write my codes in English, so I think it's a good way to start in some demos, some examples. And this is my YouTube channel, my personal YouTube channel, and this is my Nugget profile, which is I have some packages on Nugget. It's very nice. I think it's reaching 4 million downloads. That's you can check there. There's a good stuff there. So for people that are joining from Brazil, this is my website in Brazil. We have a .NET channel. We're 99.899 subscribers today.
Almost so close.
And that's it. Let's do some code here, and let's show.
So would you say you do like half and half English and Portuguese content, or like it's more Portuguese or more English, or it's hard to say?
It's hard to say. On my LinkedIn, I do some stuff in English, but most of my content on this YouTube channel here is in Portuguese, and it takes a lot of time.
Yeah, and I think it's very valuable. So like doing content in different language requests effort and time, and like congratulations for doing it, and having a big YouTube channel like that, it's very impressive. It's pretty cool.
Nice guys, and thank you for having me here. Well, can I start? That's it.
Yeah. The floor is yours. It's your show.
Great. I will do some pauses during my explanations, because this is not a true or false topic. We need to understand some points. I will show you some points regarding repository pattern, entity framework. How does it relate to clean architecture? What are the benefits? So at the end, it's not a silver bullet, and you do this way or that way, so you can mix things up. So I will explain some points. I will pause, so if you have any question, if the chat have any question, feel free. And also feel free to correct me if I say something wrong. I think it's always time to learn and grow up. Okay. So starting from the beginning, just to get started, what is repository pattern? I think some people might already know, but just to let things clear, repository pattern, I guess, is a pattern. Oh, that's it. That is the latest data access logic from business. Okay. It acts as an intermediary. This means that we create some sort of abstractions for our data. And it's broadly used among any kind of application. The first things I want to discuss about repository pattern is that you can use repository pattern in any kind of application. It doesn't need to be a big application or to have many classes or something like that. This is a very flexible pattern you can use. If we bring something here, just to draw something to you, if you have, for example, your products, okay, here, and you have some sort of access to these products on your application, if you have an endpoint, for example, and you have your database, some sort here, the repository pattern will act like an abstraction for this. So basically you say, give me the list of products. I don't want to know where it is stored. I don't want to know how you get these products. Just give me the list of products, and that's it. Another common pattern that we see together with repository pattern is unit of work, which is also a design pattern, but it manages a group of operations together. Because sometimes when we need to write something on the database, we need to mix some repositories. So in some transactions, we need to read data from products. We need to get updates from another entity. And at the end of this request, we need to make a bunch of these updates and persist this data on the database. So the unit of work acts like this. We have here the repository 1, the wrap 2, wrap 3, and so on. And all these are tied together. We're going to see this in practice in a few minutes. Okay. There's another pattern that I want to show you here. I will bring more code in a few minutes, but is the specification pattern. The specification pattern, it allows us to encapsulate some business rules in many ways, but in the way I will show you is for reading data. Not sure if you already thought about it, but there are some rules for reading also. We are very command driven to write rules when we write in domain driven design, when we write in object oriented programming. But there are some rules. For example, I just want to read the active products, or the products which have at least 1 unit in quantity in hand, or something like that. So we can write in a specification and reuse this query. This is just one point of this specification pattern, and you can say, I can simply create an expression for that and share this expression across multiple queries. But there's one point here which is very crucial for a specification pattern, which is this is very easy to test. So when we're talking about clean architecture, for example, or architecture in general, I think the most important thing we can do, or we can try to achieve in our architecture, is the testability of our code. So I don't mind to have a simpler architecture and a testable architecture rather than have a big architecture with most of things and do not have any kind of unit testing right there. So for me, unit testing is one of the most important things here and in software development in general. Okay. But let me try to bring my code here. Okay, I have a sample for you guys. I think we can. Oops, I don't want to renew my license right now. So
it's always a good moment. Like, I'm live. Let's renew the license. Yeah. Wonderful.
Let's update Windows right now.
So there was just like before you start your demo, like there was a chit chat and like people were wondering, are you drawing with your mouse or a pencil?
That's because my draw is very ugly, right?
No, it was impressive if it's a mouse. I think your writing was impressive. Your drawing was okay.
All right.
So now we know who win the lottery.
So you have a stylus. Do you have like a trackpad for your stylus or something, or like how does that work?
Yeah, I use this lock on table here.
Okay, nice. I like that.
Right.
You're muted, Cam.
But I changed the resolution so that my whiteboard got a bit messed. I'm not so bad drawing, okay, but that was just the resolution. Or you never know that.
They thought it looked really good. They were impressed by it.
Yeah, everybody was saying it was good.
I will draw more in a few minutes. Okay. Well, guys, I think that we can dig more deep here. I have here just I bring my zoom it. Whoops, zoom it 64, which is the 64 version. Okay. I have a simple application here just to show you this first example of what is repository, what is meant for, and to show you that any framework already encapsulates any repository pattern and unit of work here. So the first thing is this app, the DB context, and we have some models here in case we have just a product model. So this is more like our database, our table on our database. This is a very simple model. I'm not using any kind of modeling here, like domain-driven design, for example. It's a very simple thing. We have the mappings here, the product map, okay, to table. And what do we create here on our DB set? Okay, the app DB context here. We create a DB set of product, which is basically our repository here, because this property here, it also acts as a single point of access to our products. With this simple property, we can create, read, update, and delete our products, right? So if you ever worked with any framework before, you know that you can simple come here and say app.mappost, create your URL /v1/products, for example, and we can have our code here. Okay, I'm injecting RDB context here using dependency injection. If I'm going too fast, you can ask me some questions later. And we can call our DB context here. Okay, DB. We can have our model here, our product model. Okay. Again, I'm not focusing on architecture, this part. This is just a simple way to show you that I can access db.products. And I have add, I have remove, I have update, and I have get. Okay. projects as no tracking, dot to list async or to list will bring me all the products together. Another thing that we have here already built in Entity Framework is the unit of work pattern, because if I come here, create another model, category, for example. Okay, all right. I can go here to my DB site of category, categories, okay, my DB context. And now I can use it here. So the b.categories.add, okay, create a new category. I'll pass no here just to save some time. And just at the end, I want to save changes. Okay, I can use save changes async, which is a better approach. But what we are doing here is we are kind of transactioning between these multiple DB sets, categories, products, customers, employees, any other DB context that we have. And just at the end, we're saving changes. So what Entity Framework does under the hoods is it just uses these objects in memory. It do not persist anything on database. Just here, it will persist on the database. So basically, this is what we need on our unit of work. This is basically the implementation of unit of work. So with this in mind, we can say that Entity Framework already encapsulates the repository pattern and unit of work. So it's already built in. You don't need to create your own repositories. You do need to create your own unit of work. But I have some questions here to make you think about it, because why you should not expose your DB context like this, like is shown here. Okay. I think one of the most common things that happen when you expose a DB context is that the first thing, maybe your team is composed by a senior developer, a mid-level, and a bunch of junior developers. Okay, so that's it. That's how it works, and not everybody is aware of the of all those things that any framework is capable. So I can simply come here and say products dot to list dot where x dot title, for example, equals to banana. Okay. I'm here in Writer, the IDE, it will show me a warning here, but depends on our IDE, it won't show nothing here. So if you're exposing your DB context, in this case, the product, you will do a query on every product on your database, and just after that, you will filter. So basically, you're filtering in memory here. So you have all your products grab from the database, then you're filtering your products to show some products on your screen. So that's not good. So another thing that is missing here is as no tracking. And there's a lot of things that you can do to optimize your queries on any framework. You need to understand the concepts behind. So when you share your DB context, you're basically opening your database to other developers. So you need to be careful to things like this do not happen here. So I miss the as no tracking. If I'm using the API, it doesn't make sense. I miss, I inverted to list with where here, and so on. So this is the first most common things that happen. Okay. The second thing that happen is, for example, let me say if I want my products here, let me go back to my products and create an executive. property here. Okay, and I will say I just want the active products. Okay, so that dot's active here. Okay, I want this query here. Okay, products, just active products. Don't need the save changes here. Okay, I have a situation like that. So I want to show all the active products in this endpoints here with these products, but I have a bunch of other endpoints that I want to apply this same query here. Okay, so if you're passing the DB context, you need some sort of encapsulate this expression itself and share this with the other queries on other place. So I ever think that if I'm writing the code, the same code for the second time, it's time for create a class for it, but it's in some method. So if I'm doing this same query here, and let's say products, whatever, here, if I'm doing this for the second time, I probably create a class for it, create a method, and put this query inside some method. So let's say public class secret name. Okay, and then we can create here a method. So public list product get active products. Okay, and then we can return our DB context, and we can inject our DB context here. Okay, dot list, for example. Just a simple example. I'll show you more in a few minutes. Okay, does it make sense for you to encapsulate this query here?
Yeah, it makes sense. I was just curious because like earlier you mentioned that unit test was very important. So if you don't expose your DB context, so then how will you test your queries?
That's a good question. I'll show you in a few minutes.
Okay. Sorry, I don't want to spoil anything.
No, it's fine. So basically, what I can show you is that the secret name here could be product repository. Okay, and Frank, you just raised a good and interesting question, which is testing, and this is my opinion. I want to hear from the chat also, but I think DB contexts are a way complex to use in unit tests. It's a bit hard to mock them and to test. And so I prefer another approach that I'll show you in some minutes. But if you want to warm up with the chat, just see what guys want to use for this kind of situation. That's good also. Okay. That's it. So we have a first demo here. This is a very basic. Okay. Another point here is that data source is not only database. Not sure if you already work at you guys here. I think yes, but not sure if anybody in the chat worked on a migration before. Every time that I need to migrate systems is a headache. I never had a smooth migration in my life. And sometimes what we do is we have our products screen here. We have our checkout or any kind of CRUD here. And this is our legacy system. Okay. And when we are moving to a more modern system like microservices, for example, we created a microservice for our CRUD here, and we do some sort of integration. This is the Wrangler tree shown in Eric Evans' book, for example. And we basically do not turn a key and turn off the legacy and start. On Monday, we turn off the legacy and start the new system, the new project. We're basically recreating this part of our system, and we'll be integrating within our legacy application. So sometimes you will stop to save your product, for example, on a database, and you start to call an API for that, which is exposing by the microservice, for example. So not every time you're dealing with database here, and AppDB context is strictly related to database, even though you can switch your databases very easily with entityframework. If you tried, you can switch from SQL Server to Postgres to any other database with easy. So I think a better approach is to create a repository for that. And more going deeper here, I usually create some abstractions for it. Let me open the final version for this. What I usually do is create here a repositories folder. Okay. And inside here, create a folder, abstractions, and our product repository and product repository interface. This is also the DIP, dependency inversion principle. So we're starting to depend on an interface rather than our implementation. This will be more clear and facilitate our tests before. So basically what I have here, I know it can sound that you're writing more code, and yes, you're writing more code. If you have in a simple situation where, for example, you have a simple website that just some CRUDs, you don't need to expand, you don't need to think about clean code and any other stuff. I think entityframework fits so well. AppDB context fits so well. But for when you're increasing, when you're moving forward, using approaches using interfaces, I think is better. First, because you can expose these interfaces from your domains, from the core layers, and you can create many implementations as you want for this interface. Like you can mock it. It's very easy. So here's an example from create, read, update, and delete for the product repository. And here is the implementation using the DB context. So we have a simple EF code here. I just implemented the iProduct repository interface here. Okay. Another thing that I want to mention here that I really like is that I just expose here what I want. For example, if I am exposing the DB context, I can create, update, delete, do whatever I want. I know I can create some rules on the AF modeling, but it's easier for developers just to expose what we want here. So if I don't want to allow any creation of product here, I can simply comment this out, okay, or make this obsolete, any kind of thing. Okay, so I have a basic implementation here, and the program itself, I just did everything in the program.cs. Please don't do that in home, but it's fine. Just use the repository here, get all sync, get a sync, pass an ID, create an update. Okay. All right.
Can I ask a question real quick?
For sure.
So I was just thinking, it seemed like a really generic pattern, like the iProduct repository. What are your thoughts on having like a generic, like type parameter based I repository of T, where T is the product, and then it can be repurposed and reused and generalized.
Great. That's it's a demo here.
Okay,
Generic repository. That's the second point here.
Oh, okay. Okay, all right.
I'll show you in a second.
Okay, perfect. All right.
Because that makes total sense, right? And just recapping, this is the same thing I thought while exposing a queryable. For example, I try to avoid exposing a queryable because iQueryable is not the materialized query, so you can do more stuff with the query before materialize or execute this query in the database. And I have a very bad experience with exposing a queryable in the past because we had a very complex database, and during the query, someone has just joined a table with millions of records, and does not work very well, as you may think. We had so many problems exposing this. So even if you're not querying the data itself, if it's related to other tables, you're in a bad place. Okay, so again, this is my thought. This is my experience. Maybe in some more data-driven scenarios, you can expose your queryables to make things easy to query. You can integrate to it GraphQL or something like that. That makes sense for your business. Okay, and the last thing here is how do you test your queries? I just talked about the TIP pattern, the repository, the interface itself. But what about the queries? How we can test these queries? Okay, let me open another example here. Okay, we're running 30 minutes. All right, let's pick the Dave suggestion regarding generic repository, which just make total sense. I had some situations where I discussed this with the team, and we switched it to repository pattern. So, okay, I understand. I got that DB context is not very good to be exposed. Let's switch to generic repositories. It's partly fine, and depends on the situation you are working for. What generic repository does is basically instead of creating from the ground the product repository, I have a base implementation here of this repository, and I also like to keep an abstraction for this to facilitate my other repositories. And I build my other repositories above this one. Okay, this is very easy to do with the Entity Framework. You just have to replace product here for T. So I'm creating a generic T, and this is basically this is a generic constraint. I'm using a class here. It's not good to use a class. Sometimes I use when I use domain-driven design, I use aggregate roots here, or you can create an interface for your models doesn't allow you to create a repository for any kind of class. But anyway, for this demo, it's fine. And so if you take a look, it's very close to the other source I showed you a few minutes ago. So we basically switch it from product to T, which is a generic here. Okay, and the implementation is very easy. Also, I just have to have a DB set here of T. Okay, which is being constructed here, and then the rest of the code is basically the same. So we have dbset.add async. Okay, here I'm not using the unit of work pattern, so I'm save changes directly here and go on. Okay, dbset.remove find async. It's a very basic code. But when we move to our repositories itself, to our final implementations, we can reduce a lot of code because, for example, on my product repository interface here, I just say that this is basically an iRepository of product. So I have a basic implementation for that. By the way, I can get rid of this semicolons here, and I just have 5 lines of code. And my implementation itself, it's also here. So we don't have any kind of implementation here because I don't have any custom implementations here. It sounds to be good, and this is good in a lot of points. You can reduce the amount of code that you have, but I think when you create this kind of repository here, this kind of generic repository, you have to be careful with ISP, which is interface segregation principle. Which I did not on this demo. So I basically forced all my repos to have the create, update, delete, and get async. Okay, so I forced all my repos to do that, and this is not good because if I don't want to implement the create on my repo here, in this way I simply can't, or in a little bit better scenario, I will have to throw a not implemented exception, which is also not good. So I recommend you, if you want the generic repository pattern, to segment this on a I create, I read, I update, I delete interface and implement this. You can compose the interface implementation here. You can just come here and say, I create, oops, I read, I get, no, I update, and so on. Okay. What I don't like about the generic repository is because they are, in sort of way, very like or very similar to the DB context itself. It have a base implementation, and in some scenarios where you are very data driven, very crude based, you just to create, read, update, and delete information. This is very fine. But what I found is that in most of projects that I worked with domain-driven design, for example, most of time I ended up on creating composed versions of the repository. For example, I need to get the products, okay, but I need to get only the active products. So I have to come here and create a task, a list product, get all active async, and I have to end up with this code. And the get all, for example, these two methods here, get all and get ID, almost never used on this situation. So I think you need to balance this. You need to watch our project and see if you have a lot of things that are really similar, and the generic repository or generic code will make sense for you, or if you're just create a generic repo which will never be used itself. You will ever create some custom implementations of this repository, and that's my opinion about that. So I really take care about it. What I just do is at first I just start the repos without using a generic repository, and so if I need something like that, I implement it later. Okay, so let me see if I did not crash anything. our product repo. Okay. All right. So the program itself, you can just inject your product repo here, and you can use your product repository here wherever you want. I'm not sure if I did an abstract. Yes, I did. I also make this class abstract, so you can't create a new instance of repository FD, right?
Right.
But again,
The one thing I did notice though is like product repository was public and non-abstract, so someone could potentially incorrectly.
yeah.
So what I like to do
That's
in those cases are make them internal and sealed.
very nice, and very well pointed. So you can create it so it makes just it stays just in this assembly, right? That's it. You know, there's no. I don't think that is a it's a silver bullet here. So I think you need to understand and place it on the right place. Okay. Let me move another step here, which is using this repository pattern on our clean architecture. Okay. We are moving from a simple example using repository pattern, which again maybe sometimes doesn't make more sense because you can use your DB context for something like that. And here is a very basic example of clean architecture. I'm not focusing on show what is clean architecture. I think Cardalis and other guys did it so well here in this channel. I'm more focusing on showing the repository pattern here and the importance of the repository pattern here. So we have a rule that we need to respect in clean architecture. We cannot reference up layers from the core, from the domain. For example, this is the let me draw, because you guys told that I draw so good, so I will try here.
Well,
Okay.
it's not just your whiteboarding, but your Zoom it skills are really impressive too.
Great. It's magic. All right. If you already see any kind of drawing about clean architecture, you will see the domain here. Okay, which is the core of our application, the business rules and stuff like that. We also have application layer here. Okay, oops, sorry about that. Application layer here, and then we have the UI and the infrastructure layer here. Okay, another layer here. Infra. I'll put like that. Okay, so this is the core, the rules of our application. This app orchestrates everything for us, so it receives information. We have the infrastructure or any kind of thing giving support. So there's just one rule that we need to follow here, is that our reference is always from outside to inside. Okay, so should we pick a different color here? So it's always from outside to inside, never from inside to outside, which means our domain can reference our infrastructure or our application or something like that. So this is a very basic concept of clean architecture, but I think this is the most powerful one, because it restricts you in a way that you will end producing a very decoupled code if you follow this simple rule. Because just to saying that you can't on your domain, for example, you can reference your the implementations of your repository or something like that. I will force you to create a more clean and more testable code. Just to understand why this is so important, in this application here, I have just an API. The end of this application is an API. But let's suppose this is a large product, and I have here a .NET MAUI app. I have a Blazor server, and I have a Blazor WASM, which is my preferred here. So let's say we have three distinct kind of applications. We have a mobile application here built with MAUI. We have a website built with Blazor server, and we have an app, web app, built with WASM. I want to share the business rules with all this application. Okay, I want to share the same business rules with all this application. This make total sense for me. If you say what is the most benefits of using .NET everywhere is to share my C# code. So I have here on my domain my C# code, my business rule. Okay, and I want to share this with all my applications. Now let's suppose our domain reference entity framework. Let's suppose I have just one project that accesses our database using entity framework. I won't be able to reference this project inside my .NET MAUI application, right? Because it references end framework, I will need to ship my connection string inside there. By the way, SQL Server itself won't allow a connection from this app itself. The Blazor server, it's okay, it runs on the server, but at Blazor WASM, I won't be able to use this code also because WASM runs inside the browser, so I don't have it. So sometimes I have to use different approaches, different implementations for these rules, using different kinds of data access. For example, if I'm in Blazor WASM or I'm in .NET MAUI, for example, I want to access the API. I want to expose this HTTP, access my API from running on Blazor server. That doesn't make sense. I access the API because I wanted to make another HTTP request to my API, then go to the database and do the other all the process. So make much more sense if what we can just use these rules and access the database itself direct, right? Makes sense? All right. So following these rules, we just keep here in the domain, okay, some kind of interface abstractions and other things. Then we can implement these abstractions in other place. So this is very important for this kind of scenario that I just showed earlier, and this is to explain you why I use the abstractions on iRepository also, because for instance, if I want to access the database directly from my Blazor server or from my API, I just can make the repository like I did before, accessing the database. But if I want to create another implementation of this repository that goes to the API itself, the API endpoint, and grab me the products, it's fine. It's okay. I can have an implementation like that. So as I mentioned at the end of this video, basically what we say is, hey, give me the list of products. I don't want to know where you're finding it, how you managed to find it. Just give me this list of products, okay? in this situation here, I put the abstractions inside the domain, but this is not a golden rule, or right? You can put the abstractions. I see so many times the repositories abstractions. This here. I see it so many times here in the application layer. Okay, and for me this is perfectly fine, right? It just need to be one step below, right? If you're doing your implementation on the infrastructure. So following this pretty guide I draw you here. Okay, so what I mean here, so if we can't reference entity framework here, or even if we can reference entity framework here, we just use the interface, okay, to do that. And the implementations itself will be on infrastructure. The infrastructure product, it can be replaced. You can have, in my point of view, you can have different infrastructures for your products, for your projects, right? So if you're running a MOI application, a Blazor WASM application, you can reuse these two layers here, the domain, which contains the business rule, and the application, which orchestrates the request, the use cases itself. You can reuse these layers and just have a different kind of infrastructure, just have a different implementations of this infrastructure. Right, this is one approach. Another approach is just to have, just to share your domain, right? Which will contain your entities, all your code, your business rules, and at the end, you call the API itself, which will call the application and start all the request itself. Okay. In this scenario, or whatever other scenarios that you have, that you need to split your code, that you need to have your abstractions in a layer and implementations in the other, you can just move like this. You can have your repositories here. Here I have the repository, okay, and in here I have the product repository itself, okay. Just a few more things here. What I like to do. I did not put the internal here on the start of code. I just forgot about that. It's hard to remember all the rules. But I want to share you some restrictions that I have here. Okay, because when I use repositories, when I work with repos, one thing that I don't want is to create a repository, or to be able to create a repository for every entity or every model on my domain. Okay, most of the time I want to restrict these repositories just to the aggregate roots. Aggregate roots. Okay, so let's say you're creating an order, for example. You have the orders and you have the order lines, right? Doesn't make any sense to have a repository for the order lines, right? Because you won't be persisting the order lines by a repository. You will be persisting the order lines by the order itself. So what I do is create an interface here called the aggregate root. Okay, this is a simple interface. It had nothing inside, just to group things together. And then I create an interface for my repository. If you want to implement the generic repository, this is the place also. And here, I can put the generic constraint here, saying that I just want to be able to create a repository for the aggregate roots. itself. So every time that I try to create a repository, like in this case, I have an iProduct repository, which is an iRepository of product. The product itself need to be an aggregate root. Okay, if I come here on my entities product and remove the aggregate root, I won't be able to create a repository. It's a sort of warning to the developer saying, hey, you're not supposed to create to be creating for this entity. But if you want to go to this end, mark this as an aggregate root. This is basically signing a contract saying, hey, I know what I'm doing. I want to create a repository for this. Okay. Let me put back to my product. So this is a basic implementation here. And again, you can move your repos from here to applications layer. It's pretty fine. The abstractions, okay. It depends on many other things like domain events and other things that I don't want to mess up here. Okay. I know I'm running out of time. Just let me open more demo here, which is the specification pattern. Okay, so I think at this point we got an overview about repository pattern, generic repository, how to properly use the repository pattern on a clean architecture. Okay. The missing point here is the specification pattern. So I told you that if I, for example, I want to get all the active products, I need to have a way to put this query in a way that I can reuse this query multiple times in many places of my application. So this here, we have a specifications folder. And again, this can be on your domains if it makes sense for your project, or can be stored on your application layer. Okay. And I have a specification here. What is a specification in this case? Okay. It's basically an expression, as we discussed before. Okay. I'm just picking up that piece of our query and extracting it to this class here. So with this simple approach, I can test it and grant that every time that I will read the active products, it will work. It will bring me just the active products, for example. Okay, so I have a specification class here, which is a basic specification, and I also have an interface here because interfaces are good, and every time you want to implement something different, you have an interface. It's very good. So here I have just a two expression method, and here I have the implementation itself. In this case, I'm just checking if the product ID equals to product ID. I did with product ID. I told you about the is active, but is with I did with the ID here. Sorry about that. Okay. And at our repository, okay, we, instead of receiving the ID itself, we can receive our specification here and pass our specification to expression here, right? It's a very simple modification, and there are other ways to do that. I'm always changing my code and changing my mind about my implementations. Sometimes I a little bit shame of my older implementations, but this is just to to understand what you need to do. You basically need to have a way to test your queries and a way to reuse your queries in many places as possible. If you achieve that using specification pattern, using just the expressions, doesn't matter. Okay, the focus is to have a testable piece of code here. And let me open the unit of work. I missed it. This is the unit of work piece of code, right? This is the other scenario that we're missing when moving away from DB context to repositories, right? Because when we shifted from DB context to repos, we were basically doing our transactions, our save changes inside the repositories itself. This may works for some scenarios, but if I want to use 3, 4, 5 repos at the same request, sometimes I can't just call the save changes every moment. First, because it will lead in an inefficient use of my database, and second one, because sometimes my last code depends on my first code. So I have an order to do that. I need to have, it's not the transaction itself, because you can open a transaction using any framework also. But when you use the DB context itself, it doesn't call the save change line. You're using basically online on memory data, right? So it's kind of transaction. But we miss that when we move to the repos. So a very let me pick a key here, the abstractions. Okay, so a very good approach to do that is using the unit of work. So the unit of work, we're gonna pick all the things that are in memory using any framework and commit this thing to the database. So we basically don't need to call the save change async anymore on our repos, which is good for this situation here. This is a very simple implementation. We have many different kinds of implementations. I saw some implementations which have the repos itself here. Again, I have to understand the project to say about something about that. In most of my case, I just use the commit async. I don't even have the rollback async, because at the end of the request, any framework will dispose all the data in memory, so you don't need to do a rollback here. So it's just an interface with a method inside. Yes, that's it. This here is the implementation of the unit of work itself. So I have the implementation of that interface we just showed you, and here I just have the context.save change async. So it's a slightly move where we moved our save change from our repos to this class itself. Under the repos, if I go to the product repository, for example, I have the create here, but I don't have the save changes anymore. Okay, I just have the context.products.async. If you let this code this way, it won't persist on the database, because I never call the save changes in my code. So what do we need to do? I have a use case here. A use case is basically an action that we can execute on our application. In this case, an action resulted by create a product. This action will interact with our domain, with our business rules, and our infrastructure to persist our data. So we have here an input, which is our comment, the request itself, and the response itself. Dummy code here The comment is just the title of the product, and the response is just a message saying, hey, your product was successfully created. So on the handler method, as you may notice, I have the product in repository, but I also need the unit of work here. So I receive the unit of work, I receive the product repository, and then here I can receive many other like I category repository. Okay, and any other repositories that I want, and I can sort of transact between these repos. So I can start here, create. This is the basic implementation of the product itself, the basic creation of the model. Then I can use the create, pass the product. Remember that the create method doesn't call the save change async. And at the end here, we have the unit of work that commit async. Okay, so we shifted the save change asyncs from here. So I can call whatever repositories that I want and just save changes at the end. This means that we are also sharing our DB context here among our repositories, right? And just 2 more minutes, I promise you. Let me open the last one here with unit testing, right? So I just created a simple project here to show that the infrastructure test. Again, you can test your domain, application, API. You can even test your architecture to grant that your domain is not referencing your infrastructure, for example. But in this case, I want to show you the specification tests. Okay, so I have that same implementation using the specification pattern. And we can use Mock and Bogus, any mock framework here. I just explicit mock up this code to show you under the hoods what is happening here to make more clear to test. So I can create a simple test here, this to grant you can get the right product by ID. It's not getting the wrong ID, or it's not getting the brand ID, something like that. I can create a unit test to test every query that I want. So if I want to test, for example, just the active products, that the product is with less than 3 units in stock, whatever I want. So as we are using expressions, that I can come here, convert my products, which is my setup here. I have a GUID, fixed GUID here to create my first product. So I'm creating the product 1 with this GUID, which means when I execute this query, it should return just the product, and this product should be the product 1. Okay. So I have my setup here, and here I have my products.s my queryable, because I need queryable to specify the expression here, and here I have my expression to test. So, and here I can pass any GUID and expect my product to be null, right? Not null here and null here. And I can run this test. This is the time where the test fails and my face got a little bit. No, that's it. It's passed. Okay, there. Just 2 simple tests here, just to show you can test specifications, right? Like I did here. And you also can mock your repositories to test your use cases. For example, if you want to test this use case here, this handler, right? So if you want to test this, you can mock this product repository here, and you create a fake repository for it. Because one fact about unit testing is that you can't depend on your database for unit tests. It's not that you can. It's not a good practice. Your tests need to run fast. You need to run smoothly. Sometimes it impacts on your build time because you're running your tests after your build before deploying your application. So you need to run as fast as possible. So many times we don't have the production data on our QA, on our dev environment, so we can depend on our database. So we can use interface to mock here. This is more like the IP patterning action here than unit test itself. So that's why I brought the specification here. That's it.
That was awesome.
Wow. So many information.
That's it. Drop the mic. Walk away.
Yeah, just
No, for
boom.
sure. And so I didn't want to interrupt, but I don't want the audience to think we ignore them. So there was this raging debate over in the chat about repository pattern, and I'm just going to pop up some of the messages here. We don't have time to go through it all in detail, but there was this raging debate about repository pattern and whether or not it's overkill and whether or not it abstracts away EF core features, because like how does the caller know that the entity is being tracked? And I was wondering if you had any thoughts toward that specific issue before we call it.
Yeah, that every time that we talk about repository versus entity framework, this is a big war, what I think is I don't take any kind of implementation as a golden rule, not even the clean code from Robert C. Martin, which is I perfectly agree. But for every scenario that we have, we need to understand the scenario, and we need to make a code that fits for this scenario and that makes sense for this scenario at this time. One thing that I try to avoid is if one day we need to change it. Okay, if one day we need to change the database, that day we're gonna change the database, and okay, for now we're gonna speed up our development with entity framework, and that's fine for now. Okay, so try to analyze your situation right now. And architecture is not a thing that stops in time. For example, you can start your planning your architecture for now. Start with clean architecture. Start with entity framework in DB context. This is pretty fine. It's okay. If 2 weeks, 4 weeks later, you need to move to repository pattern to generic repository itself, that's fine. It evolves with the time. Okay, just doesn't forget about this topic here. This is the most important. If you have a good test coverage, you can change basically everything on your code because you cover it, right? So that's why what I think about entity framework and itself. Do you lose something moving from entity framework to repository? For sure, because entity framework is is a framework. It gives us so many things regarding the database. It basically gives us all the possibilities that we have to query the database. So when we move to repository pattern, basically what we're doing is to encapsulate some pieces of the entity framework and exposing just what I want. That is why we want to create this boundary around the entity framework itself. And this is need to be analyzed to make sense to your business and to your project.
Agreed.
It was such a great episode. The chat is still going. It's on fire. You know what, André? I think we'll have to get you back and maybe elaborate on when you're migrating between different patterns and something like that, and take more time to answer all those questions.
Yeah, for sure.
I will say a big thanks to you. Maybe we can put some link in the chat. I cannot do that, I think, but David, Cam, if you can put some link in the chat. Thank you a lot for you sharing all your knowledge and sharing with us those patterns. I think they are very important. Thank you for all the chat for like making that episode very dynamics. We need you to be there. And yeah, that's a wrap up. So next episode, I think it's on the 14th, if the notes are okay. And it will be Lila Porter. And she was working on a game. So I'm not sure if do you know, David, if the episode is also about like a...
I don't actually know. I'm not certain. I just know that Layla, I believe, is the next one. I don't think there's a show next week. So awesome.
So excellent. So come join us. And next week, we have plenty of episodes that are available on YouTube. So take the time, go there, watch something, and see you on the 14th. And with that, have a good week, everybody.
Bye.